Hello, we are going to look at some more factorising. In a previous video we looked at highest common factor, but we're going to look at a type called grouping today. Now grouping is really just highest common factor being done 3 times. So when we're faced with a grouping problem, it typically has 4 terms, something like this: first term, second term, third term, fourth term. Now, anyone looking at this might think, well, couldn't we just put those two together to get 45x? Yes, we could. And we're going to see in a few minutes why I've chosen this example. Okay, so looking at this, we got 4 terms. Okay, ignore the fact we can simplify that. Now we're going to group them together. We're going to look at these 2 terms together. We're going to do the highest common factor. Look at these 2 terms together and do the highest common factor. So, highest common factor. So if you look at 8 and 48, a list of their factors shows that 8 is the largest factor. If we look at x squared and x, again, x is the largest factor, the highest factor. So we're taking 8x out. Now 8x by x will give you back 8x squared. 8x times 6 will give you 48x. Similarly here, the only common factor is 3, well 3 and 1, 3 is the bigger or the highest. So taking it to number 3, 3 goes into 18, 6 times, 3 goes into 3, once, the invisible 1. Why has this sign suddenly changed to plus? Remember that when we multiply minus by plus we get back minus. If I kept the minus here, I'd have a problem. Minus by a minus would end up being plus, so the signs would be wrong. So we just need to make sure that we are using our signs correctly. So that's highest common factor once, twice, but we can see now that this bracket is the same as this bracket. So this is now the new common factor. This long term here, this second term, again they're quite long, but the common factor is x plus 6. So I'll factorise that out to the front. Then I'm left with these 2 terms. So we could ask ourselves, is this genuinely equal to what we started with? So if we want to check it, we need to multiply that or simplify. If you've watched our factorising videos or simplifying videos, you'll see that we've done a lot of these. We're just making sure that this x is multiplying both terms, the plus 6 is multiplying both terms, that's happening here. The x is multiplying both terms here, so we're rearranging it, but it's the same thing. Now we're actually going to multiply x by 8x, 8x squared, x by minus 3, 6 by 8, 48x, and 6 by minus 3, minus 18. So we have got back exactly what we started with. You might notice that the minus 3x and plus 48x have changed order or position. That's okay. That's allowed with additions here. And if you notice, the minus is still with the 3x. So even though the 3 is moved, the minus has gone with it. So it's fine. You can rewrite that as this if we prefer. So that is definitely the same thing as what we started with. It still gives you 45x like we were mentioning earlier. Or if you preferred, you could have done that here. We could have done 8x squared. These 2 terms together give you plus 45x minus 18. So it works the same both ways. Let's take a look at another example. So here's another example of grouping. So common factors here is only a. So again, we've grouped those 2 together. Now grouping these 2 together, I'm going to do the highest common factor another time. So we've done the highest common factor once, going to do the second time. What's common here? The y is common. So we have grouped these together, done highest common factor, grouped these together, done highest common factor. And now we see in the brackets, we compare this term to this term. We have a new common factor, a minus 1. So we can do highest common factor a third time. The a minus 1 comes out to the front. It's now multiplying. To recreate the two terms above, we have to multiply a minus 1 by a, recreates this term, a minus 1 by y, it recreates this term. Check your work. A multiplying both of these, minus 1 multiplying both of these, and so now just multiply out a by a squared, ay, minus a, minus ay. Now it's the same as what we have above. We made a mistake there. Minus 1 by y is just minus y. So we have the same thing. We have our minus y, have the minus a, have the plus ay or ya, same thing. They're both plus, so they're the same thing. And we have the a squared. So we could rearrange it if we wanted, so it looks like it does above. We can reverse the y and the a if people feel more comfortable or happier with that. So it looks just like it does above. Okay, we have another example of grouping here. To solve, we just do highest common factor 3 times. Pause the video and try it. Using our factors to get the highest common factor, the 2 and the x. You can see we're left with the 3 and the x, our blue ones, and the 7. So we can just check that 2x by 3x, 6x squared, 2x by minus 7, minus 14x. We can do the same thing over here. So looking at factors of, for instance, ax, it's just a times x. Factors of a, of course, is just a times 1, so what about the 21? 1 times 21, 3 times 7, 49, 1 times 49, 7 times 7. So we can see we have highest common factors a and 7. And if we're using those factors, their complementing factors are x, 1, 3 and 7. So let's see how we use that. Notice we've got a minus and a plus. I'm going to take out a minus because inside my bracket I want to make sure I come back with a plus. Minus by minus will make plus, and it will give me the same sign as here. So that's the reason I'm choosing those signs. I want to get the same sign here and here. If I went with a plus here, I'll end up with minus and plus. Plus by minus, get back minus, and plus by plus, will get back plus. But now the signs are different. So I'm going to select the minus. That way, minus by plus will make minus, and minus by minus will make plus. They're the multiplying rules for signs. Make sure we only use them when multiplying. So I'm going to get the same signs, a plus, plus, a minus, minus. Of course, we don't show this plus. We don't need to show this one either. Let's do our factors though. Our common factor was 7 and a. 7 and a. So we're going to get 7a. And the complementing factors there, for the 21, the complementing factor was 3. For the ax, the complementing factor was x. For the 49, we've taken it to 7 already, but then the complementing factor is also 7. And for the a, we took out a already, so we're left at 1. Now remember, if you put a 1 in here, 1 times 7 is just 7. We don't need it. So just to highlight so people can follow, there's our common factor here, and there's the complementing factors that went with them. We just need to be careful with the signs. Of course, we had the same before. That was our common factor, and when we did our list, they were the complementing factors. Now looking at what we have here, we've done highest common factor once, we've done it a second time. We can see now that we have a new common factor. We can do highest common factor a third time. We just need to take this bracket out to our front and multiply it by the 2x and the minus 7a. And so we have fully factorized it now. We partially factorized here and here, but we now fully factorized. If we want to check our answer, we need to multiply those out again, and we should get back what we started with. Let's do it. 3x has to multiply both terms. The minus 7. It also has to multiply both terms. 3x by 2x, 6x squared. 3x by this, minus 21xa. Minus 7 here by the 2x. Minus 7 by this, minus is plus 49a. And this is the same as what we have above. The order got jumbled up a bit. You can rewrite the order if you want. Notice we can also change xa for ax, they're the same thing. So that is factorizing by grouping. And again, it's just highest common factor once, twice, and a third time. And that's your answer here. This is just checking your work. So it's nice to check our work, but that's not part of the factorizing. In fact, these steps are simplifying, which is the reverse of the factorizing. So I hope that was helpful for factorizing. I want to go back to one of the examples we had already. So factorizing quadratic trinomials. What's a quadratic trinomial? Well, anything with an x squared is a quadratic. If the highest power of your variable is squared or power of 2, that's a quadratic. So that explains the word quadratic. Now, x squared is quadratic, so is something like 8x squared. That's also a quadratic. If you've got a quadratic maybe with minus 4, it's still a quadratic. If I stick a plus 2x here, it's still a quadratic. So let's take a look at an example there. That's still a quadratic. It's not a trinomial. Tri means 3, so we've got 2 terms here. But that is a quadratic. If we stuck another term in here, then we'd have a quadratic trinomial. This question came up during the summer on the Junior Certificate higher level paper. They're also very common on Leaving Cert ordinary level. So a very important question for examinations, and they just naturally arise in a lot of real life situations. That's why we study them. Notice that the power of x squared, that's what makes it quadratic. The fact there's 3 terms is partly what makes it trinomial, but also look at the powers. We've got power 2, power 1, and we never really do this, but there's a power of 0. X to the power of 0 is 1, so that's the same as just having minus 18. That's so important. We want to learn how to factorize it today. So we want to look at these quadratic trinomials, we want to factorize them. We're going to use a method called guide number. Okay. Now these are often said to be in the form ax squared plus bx plus c. Here a is 8, b is 45, and c is minus 18. So the signs are important. So a is really plus 8, b is plus 45, and c is minus 18. So with guide number we just multiply our a by the c. In our example, 8 multiplies by minus 18 to give us our guide number. Plus by minus is minus. So we're going to work with this guide number a little bit before we attempt to solve our quadratic trinomial. So looking at minus 144, I want to look at some of its factors. what two numbers multiply to give me this. It could be minus 1 by 144. Okay, so we said we'd look at the factors of our guide number. We've put them on the screen. Next we're going to take a look at what happens if we did the total of these. So like 144 take away the 1 would be 143. Minus 144 and 1 would make minus 143. These make 70. These make minus 70. Together these make 45. Together these make minus 45. And so on. We get 32. Minus 32. We do the same here. Okay, so we've got all the different totals put in. Now, one that's of interest to us here is this plus 45. It appears here. This will allow us to do a substitution in a moment. So I just want to focus on that. None of the other factors are of any use to us. Why is this useful? We can now replace plus 45x with minus 3x plus 48x. So minus 3x plus 48x would give us a 45x. This is going to help us change this problem and turn it into a grouping problem. So let's remove all of our factors. Just make sure we know the guide number was 8 by minus 18 minus 144. In black here we have all the factors of minus 144, finishing over here with 12 times minus 12, and then in blue we're looking at what we get if we total those up. Minus 2 and 72 plus 70, 2 and minus 72 minus 70, and so on. And the one we notice that's curious is to get the number 45, which appears in our question. So we're going to use this fact here. So leaving this on screen for a moment, we're just going to see our substitution. We'll still have 8x squared, but instead of 45x, I'm going to have 48x, that's a plus 48, and a minus 3. Those two together give me plus 45x. I still have the minus 18. So we have done a substitution. We have replaced plus 45x with the two of these. Now they're equal, so that's a fair substitution. How did we find it? We found it with our guide number. It was our A, or 8 times the C, the minus 18, and we multiplied them to get minus 144. We looked at all the factors of 144 in black, and it included minus 3 times 48, and in blue we looked at what's the total of these. We add them up, minus 3 plus 48 is 45. So we can see that we can then do a substitution. Okay, so this is some progress. We can now look at this as no longer being a new type of factorising, but from here we can solve it using quadratic. We can solve it using grouping. So we're going to group these two terms together. Take out our 8x, leaving us x plus 6. Group these two together and take out minus 3, leaving x plus 6. Of course, grouping is just highest common factor done once, done a second time, and now we have a new common factor. So let's do highest common factor a third time. Let's take this common factor x plus 6 out to the front. I'll be left with 8x minus 3. 8x from here, and minus 3 from this term. And of course you can multiply that out, we should get back exactly what we started with. So multiplying these, x must multiply both terms. 6 must multiply both terms. So x times 8x, 8 times minus 3, 6 times 8x, 6 times minus 3. And these two terms, they're the same type. They have the same powers. The signs aren't important, the numbers aren't important, it's the powers and the x that make us determine that they're the same type. So 48, take away 3 of them, we have 45 of them.